Hello and welcome to this BioProcess International Ask the Expert webcast. I'm your host, Jordan Stillman, Digital Products and Marketing Coordinator for BioProcess International. Before we get started, just a couple of notes. This webcast is being recorded and will be available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the question and answer window on your screen. Please enter your questions at any time. Your questions in the question and answer window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Rob Martindale from Masterflex.
Thank you very much. Good afternoon or good morning, depending on where you are in the world. Thank you for joining me for this webinar entitled Improve Productivity and Operational Efficiency with Single-Use Technology. As the title suggests, our focus today is on single-use technology. I will be taking an in-depth look at what single-use technology is and what it means for a typical production environment. Over the next 30 minutes, I will be looking at how you can achieve some of your goals of controlling cost, increasing production yield, and operational efficiencies through the adoption of single-use technology. My name is Rob Martindale, and I'm part of the product management team here in the EMEA for Masterflex. So regardless of what stage of manufacturing you may be considering, the topic of enhancing productivity is constantly on the minds of many who work in the production environment. The ways you can positively impact that question may differ depending on the stage of manufacturing, but regardless, there is a constant focus on making improvements to the overall productivity experienced on site. So when it comes to making improvements and enhancements to overall productivity, there are typically some common buckets most companies look to fill. For example, one focus area is looking for ways to reduce downtime. And by downtime, we mean time where there is no active production of the final product. Most often, downtime is directly related to the cleaning and preparation steps that must take place between production runs to eliminate the sources of cross-contamination. Since reducing downtime would typically lead to the increase in the amount of time where full production can take place, this certainly helps you work towards the goal of enhancing productivity. Another common focus is on making improvements to the productivity workflow. In truth, manufacturing anything is a complex process, as there are often many working and moving parts of a production machine that must work together to achieve the best results. Yet another common focus area is increasing production yield, as this speaks to the constant drive towards making the production process as efficient and effective as possible. Obviously, if I can produce more viable finished product in the same amount of time, not only does my overall revenue grow, but my revenue per hour also improves, as does my profitability. And of course, directly related to increasing production yield, and an area everyone looks to improve, is cash flow and profitability. While increasing production yield can certainly help achieve the goals related to this focused area, there are also other ways to positively improve cash flow and overall profitability. While each of these four main areas are often looked at individually, it's important to note that incorporating single-use technology can actually help you make strides in each of these top priorities. Therefore, it's worth looking at all of these areas holistically. So, why should single-use technology be incorporated into a workflow? Well, I'm going to explain why this needs to be considered. One reason to consider incorporating single-use technology into your workflow is because of the way your overall manufacturing operations and procedures can be simplified. Often, fluid pathway assemblies can be complex, incorporating numerous components. Because fluid pathways can be so complex, installing the needed components often takes a lot of time to do correctly and can also be tedious for production line engineers to focus on. From gathering the components together, to preparing them, cleaning them for use, to assembling the components together, testing the fluid pathways for integrity and correctness. There are so many steps in the process that can either be mitigated or avoided altogether by simply utilizing single-use assemblies as part of the build-out of a standard manufacturing workflow. Of course, most of us are familiar with the phrase time is money, but many people are rarely stop to consider the true implications of this phrase. The truth is that every step taken by personnel in the setup and daily operation of a standard manufacturing workflow adds to the overall cost of the production of a biotherapeutic. Just like all the steps discussed in the last slides, it's easy to see how doing the assembly work to a fluid pathway using just raw components can not only consume valuable time, it can actually cost the company much more than originally thought. As the increased time both reduces overall batch profitability, but also reduces the overall production capacity for a facility. Through incorporating single-use technology in the most standard workflows, a company can realize a saving in both downtime and uptime, and both of these savings can collectively add to the site's bottom line. One of the key drivers in nearly every stage of biopharmaceutical development is ensuring maximum production time and maximum production yield. To that end, continuous improvement of all processes and steps of manufacturing is a daily topic and challenge. In short, companies are continuously looking for ways to improve their ability to produce product. One resource companies cannot purchase is time. Therefore, one way of saving time is by using single-use technology. Not only can companies realize an increase in available production time through incorporating single-use technology, but a company can also realize improvements in production yield as fluid pathway assemblies that have single-use technology within them are cleaner, more consistent, and less prone to contamination. So in addition to reduced validation work, cost savings, and increased production and yields, there is also benefit of reduced contamination. Within bioprocessing, when we talk about contamination, we're talking about cross-contamination, microbial contamination, and process facility contamination. For example, imagine a scenario where a manufacturing plant creates multiple end products, and in between each batch, they carry out a lengthy clean-down process of the manufacturing line. Well, this introduces a risk of contamination, and it's this risk that is removed through the use of single-use technology. This risk reduction can also be implemented within more traditional application lines, where hard pipe lines are used with large stainless steel bioreactors and holding tanks, for example. By introducing single-use technology in small sections throughout that manufacturing process, where the risk of contamination is perhaps higher, risk mitigation can be achieved. The advantages of single-use technology don't stop within the areas I've just mentioned. In fact, this slide provides some additional benefits to the incorporation of single-use technology. The big story is that a single-use technology can help you save time, save money, increase productivity, and reduce hassle and frustration. With all the discussion around single-use technology and single-use assemblies, you might wonder, where are the most effective places to use single-use assemblies in a traditional workflow? Well, on screen, you will see a representation of a fairly traditional biopharmaceutical workflow. From the initial stages of cell growth to purification and harvest, and finally ending with fill and finish. At each stage along the way and within the gaps between the different steps, fluid transfer typically takes place, which means that many standard workflows have several places where single-use assemblies could be used. So what makes up a single-use assembly? Generally, there are three main groups of products that go into a single-use assembly. The first and most significant component is the tubing. and this is typically manufactured from materials such as silicone or PVC. The second group of components are items such as fittings, connectors, filters, and other key accessories that will make up the integration into the workflow possible. The third group of components are more specialized accessories, a group that includes various essential sensors that might be needed to keep an eye on flow rates and inline pressures. We can't forget to mention the use of a peristaltic pump that are often used within single-use systems to move fluid from A to B. Peristaltic pumps, such as those manufactured by Masterflex, are a perfect partner for a single-use system, as these provide convenient, non-contact fluid transfer that is robust yet gentle on the biological material that's been metered. With flow rate ranges that span from microliters per minute up to many meters per minute, peristaltic pumps can be safely used throughout most areas of traditional biopharmaceutical workflows. Now, because of their importance, let's have a closer look at the first two groups, the tubing and fittings. The first and most common component that is included in a single-use assembly is the tubing itself. The tubing is typically nominal sized, with smaller tubing used generally for research and development, and larger tubes sizes mostly used when moving up to pilot plants or full production. Another key consideration when choosing tubing is, of course, chemical compatibility. In biopharmaceutical applications, the most commonly used and most widely accepted materials are typically silicone-based, with platinum-cured silicone tubing being the most popular due to its well-tolerated chemistry and biological materials and lack of leachables and extractables. In addition to the tubing, the next most commonly included components in tubing assemblies include fittings and inline accessories, such as valves and filters. The fittings are available in many configurations to ensure compatibility with the process line, from traditional threaded connections to barbed connections to sanitary and pipe threaded connections. Many different options are available. Other components include essential accessories such as inline filters and items such as clamps and valves, which can be utilized to manually shut off fluid flow along a given pathway. Both this slide and the next slide highlight some examples of more commonly used accessories in this category. Imagine having to stock all of these in a GMP environment, making sure the stock is available at the right time. Not only that, but then assembling these correctly with the right tube. This can take time and can cause problems for biopharmaceutical manufacturing. Everyone could stock these, given enough space and time, but the beauty of single-use technology is that suppliers such as Masterflex take all of those problems and delivers you the end product when you need it, with confidence, having assembled all of the components in ISO Class 7 clean rooms with dedicated staff and facilities. And don't get me wrong, this doesn't happen overnight. Masterflex, for example, would assist and work with the end user to make sure that the design and specification of a single-use assembly is tailored to their process needs. Ultimately, the central message is that single-use technology can truly be implemented throughout your traditional workflows and can help you achieve process improvements, enhance your overall productivity, and even result in significant cost savings and improvements to revenue. To better understand the financial benefits that can be realized through single-use technology, let's take a look at a specific example that illustrates these benefits. In our example, Company XYZ is a contract manufacturing organization. In their production process, they have identified 10 areas in the fluid pathway of their workflow where a single-use tubing assembly might be beneficial. And they would like to examine and compare the costs between having Masterflex manufacture the tubing assembly for them versus continuing to assemble the tubing assemblies themselves on site. The assembly they would like created for them looks similar to what is shown on the diagram on screen. The overall assembly is approximately 1.5 meters long, complete with 2 sanitary fittings secured, one on each end, and with an inline filter capsule to capture stray particle matter. When comparing the two options, the first layer of comparison is the initial purchase price for each. For this comparison, the option offered by Masterflex would cost the customer €25 for each assembly, where the purchase cost of just the components used for the tubing assemblies when assembled in-house at company XYZ is €5.50. So just looking at the purchase price would make the Masterflex option over 5 times the cost of the components. But if we're truly to understand the true cost of ownership, we need to ask if there are other things to consider beyond just the initial purchase price. For example, one question to consider is what are the labor costs involved when assembling those components? Well, let's look at this a little bit closer to better understand what those costs are. When looking at the labor costs to properly install each option, things start to get a bit more complex. For the Masterflex single-use assembly, the only real labor cost involved would be opening the package and connecting the 2 exposed ends of the sanitary fittings to the equipment in the fluid path. But if the tubing assembly is being manufactured from raw components on site, then there are other labor costs to consider, including things like the labor to prepare the individual components and assemble them properly, the labor costs related to performing gamma sterilization on the completed assemblies, the labor costs to test the assemblies for integrity, and the labor costs to perform complete installation. Not to mention the associated costs with procurement of the components from multiple vendors and performing routine inventory management on all of those components. For the purpose of this scenario, we will assume that the assembly technician is being paid a fully burdened labor rate of €65 per hour. Now, this includes both salary the worker earns, as well as extra costs to company XYZ incurs, for example, insurance, training, resources for the worker, for example. Looking at this more closely, it is estimated to take up to 6 minutes to open the packaging and properly connect and test a Masterflex single-use assembly. But for the same assemblies to be made on site by company XYZ, the total time investment per assembly is estimated at 30 minutes. In large because all of the separate steps that must be factored into the process. Now that we know the estimated time to properly assemble and install each option, and now that we know the fully burdened labor rate, we can perform some simple maths to determine and understand the full labor costs to properly install 10 assemblies needed per batch. For the Masterflex single-use assembly, with an estimated 6 minutes per assembly needed at €65 per hour for the labor rate, it would take 1 hour to complete the work and cost a total of €65 to complete the installation of 10 tubing assemblies. But for those same tubes to be assembled and installed on site, the cost would be substantially more. At 30 minutes per assembly needed for a complete installation, it would take 5 hours to complete the assembly and installation, which at €65 per hour would cost €325 to complete the installation of 10 self-made tubing assemblies. Now, let's take a fresh look at what the true total cost of ownership would be for each option, adding the initial purchase price and labor to install each option. For the Masterflex single-use assembly, the initial purchase price is €25 per assembly, making the per batch purchase cost €250. Then adding in 1 hour for the installation labour of €65, it brings the total cost of ownership per batch at €315. However, for company XYZ to fully manufacture and install the tubing assemblies on site from raw components, while the initial purchase price of the components is only €65 for all 10 tubing assemblies needed per batch, the labour costs are estimated at €325. When we add these all together, it makes the total cost of ownership for the self-manufactured option up to €380, which is €65 more than the Masterflex option. And of course, aside from the overall total cost of ownership calculations we just did, there are other benefits to using single-use assemblies sourced from Masterflex. For example, the Masterflex tubing assemblies would arrive fully sterilised. Company XYZ would only need to place one purchase order for everything when purchasing the full assemblies from Masterflex. There would be more time available for actual production, since the tubing changeovers would take less time. Less time would be needed to train individual technicians on the installation procedures, and it would be easier to validate the integrity of the fluid pathway when utilising fully assembled tubing kits from Masterflex. These are just some areas where additional value could be realised when using Masterflex single-use technology. The big central message is that Masterflex single-use tubing assemblies, while having a purchase price that is significantly more than the price of the individual components, can actually benefit customers in multiple ways. Masterflex tubing assemblies can save customers valuable time. Masterflex tubing assemblies can save customers on the total cost of ownership, and Masterflex tubing assemblies can provide overall simplicity of use, further reducing costs and improving the overall workflow at the same time. Thank you for listening. We can move to some questions now, please.
So Rob, the first question I have here is, how long would you expect the delivery process to take from initial inquiry to delivery of SUT?
Well, great question. Thank you for that. It would really depend on the complexity of the assembly. The ordering process can be broken down into 3 stages: design and consultation, validation where the customer validates the assembly, and the third step, supply planning with lead times and manufacturing. So the design and consultation discussions could be completed within 2 to 3 weeks. The validation phase, well, here we would work closely with the end customer to assist the validation phase of the single-use assembly in their facility. This time would be dependent on a number of factors, therefore it's hard to put a date or timing on that. And then once the assembly is validated, would work with the supply chain to make sure the order quantities match your expected requirement before going into manufacture. Masterflex does stock many fluid handling components such as tubing, fittings and filters and bags. So they are available when needed in order to reduce any possible lead times. So I hope that answers that question for you.
Awesome. Thank you so much. So the next question I have is, why are manufacturers and suppliers such as Masterflex, among others, better positioned to provide SUT than the pharmaceutical manufacturing company?
Well, great question. Masterflex has a very large selection of single-use components from a broad range of carefully selected brand partners. This means our design will fit your process and the supply of your assemblies will remain uninterrupted. Assemblies are delivered with complete validation documentation. All kit assemblies are carried out in clean room environments and spot checked prior to shipment. And we also offer 3 levels of sterility. So from kits assembled in the clean room to kits assembled in the clean room and then sent to gamma irradiation, and then a third option of kits assembled in a clean room environment sent for gamma irradiation, together with the sterility assurance documentation then supplied with the assemblies. And all assemblies are supplied double bagged. And to end that question, I mean, this is our main focus. Therefore, what we do and how we do it is of utmost importance to us. So, we're 100% focused on the end product for our customers, which puts us in a strong position to be the supplier for your single-use assemblies. Thank you.
Great, thank you, Rob. Okay, I think we have time for just one more question. So at which point would you suggest a single-use assembly becomes too big for the manufacturing company to assemble themselves?
I would say this answer really depends on the scale of the bioprocessing manufacturer and the demands of their product. If time isn't a concern, then I guess it is possible for them to assemble smaller single-use technology assemblies. However, as we've covered within the presentation, time isn't the only factor here. As the complexity of assemblies increase, as does time, cost, contamination risk, complexity of the assemblies and the components. Therefore, I think the tipping point where companies accept or decide it's time to move over to pre-assembled systems from a supplier would become apparent during the manufacturing process, or when the manufacturing teams look at the procedure, look at the scale of the workflow, and kind of assess the situation and say, we can save time, money, resource, and risk by moving to single-use assemblies from a trusted supplier such as Masterflex. I hope that answers your questions. Thank you.
Fantastic. Well, thank you so much, Rob, for joining us today. And thanks to our audience for joining us as well. The recorded version of this webcast will be available for on-demand viewing on our website. And as a registered attendee, you will receive a follow-up email providing you with a direct link. We look forward to having you join us at our future BioProcess International Ask the Expert webcasts. Look for those announcements in your inbox. Goodbye.